Bienvenido a un nuevo contenido de Uninorteco. No olvides suscribirte a nuestro canal.
Welcome to a new session of PiA Webinar Series. Before I introduce our guest, I want to remember that PiA is a joint academic initiative supported by the Asociación Argentina de Sedimentología, sin staff from Mexico, el Instituto Argentino de Oceanografía, Instituto Geofísico del Perú, Mississippi State University from United States, Universidad de la República from Uruguay, Universidad Federal do Espírito Santo from Brazil, Universidad de Costa Rica from Costa Rica, Universidad del Norte from Colombia, Universidad Técnica Federico Santa María from Chile, and Sequoia Scientific Inc. from the United States. I want also invite you to visit our webpage in order to know many initiatives in the continent, as well as to visit the past webinar of our PiA Webinar Series. Today, we have Naciano Filisola, Rogero Marino, and Nayara Diniz. They are going to present a look at the Rio Negro sediment contributions to the Amazon, some preliminary results. In behalf of them, it's great to us to introduce Dr. Naciano Filisola. Naciano Filisola is professor in the Department of Geoscience at the Federal University of Amazonas. He is leader of the research group on hydrosystem and human in the Amazon, coordinator of the graduate course in geoscience at UFAN. He also collaborates as a teacher in the graduate program in climate and environmental at the National Research Institute of the Amazon. He is PhD in hydrology and geology from the University Paul Sabatier from Toulouse, France, master in regional geology and geology from the University of Brasilia. Naciano works mainly in projects on dynamics and fluvial geomorphology and water resource management in the Amazon since the 1990s. He has published more than 100 technical and scientific papers and is a member of the scientific committee of the Governmental Program for International Cooperation and of the International Coordination of the Observatory of Geodynamics and Hydrology of the Amazon Basin, (HIBAN). Is member of the State Water Resource Council of Amazon and of the Management Council of the Anavilhanas National Park at Rio Negro. Member of the Technical Committee of the Amazon Fund, advisor of international and international relations at UFAN, advisor to the direction of the National Water Agency, and ad hoc advisor to the Hydrology Commission, of the World Meteorological Organization, as well as a member of the management group of the National Hydrometric Network. It's a pleasure for us having you, Naciano, in this series of conference. Naciano is also a great and a marvelous person and talker. Naciano, welcome to our webinar series.
Thank you, Juan. Thank you to everyone. It's a pleasure for me to be here. Thank you for the invitation, and I hope I can give you some good image about the Rio Negro River Basin. So, well, I can start. If yes.
Yeah, Naciano, please go ahead.
Okay.
You can share your presentation.
Yes, I'm going to share the presentation with you. That's okay?
Yeah, Naciano.
All right.
can see
so this
Go
is
ahead.
part of initiative done by us at the university, the Federal of Amazonas State in Manaus, here in Manaus, in the Amazon state. And we have the participation of the Brazilian National Water Agency here, the ANA. And we also have the Brazilian Geological Service Corporation, and also the graduate programs here and from the INPA as well, and the HIBAN Corporation, the IRD from France, and the Brazilian Environment Development and Maintenance called ICMBio. And I am going to show you some data and some information we collected from the Rio Negro Basin since 1918. More, in fact, we have some data from the 2013. So this image, for example, is here we have the Rio Negro in the upper river area at the São Gabriel da Cachoeira in 2018. Just to introduce a little bit the theme, we have to take a look about the Negro Basin just to justify why we are now studying this area, especially because Negro is the biggest tributary of the Amazon with black waters, and probably one of the biggest black water rivers in the world. So in terms of area, the Amazon Basin is a 6 million square kilometers basin in area, and the Negro represents 11% of this basin. And in terms of water discharge, it represents 40% of the basin. So it's a very interesting thing to compare with the Madeira, for example. And the Negro is almost a basin in Brazilian territory, almost 90% of the basin in Brazilian territory, but the source comes from Colombia. And what is interesting here is that the Negro, we have 14% in terms of water discharge, but 11% in terms of area. And the Madeira, we have much more big area, but almost the same contribution in terms of water discharge. Here we can see some image from the Rio Negro, and the hydrographs normalized from some of the stations we investigate in the Rio Negro Basin. Here, for example, is Serrinha in the middle of the basin. So we can see here that the highest period in terms of the river water level is in the middle of the year, as well as in Barcelos and Moura. But in Manaus, here we have a difference from others because of the influence of the Solimões here. I mean the Amazon that blocks the backwater effect that causes a retention of the Negro's waters. Here we can see one of the reasons for that difference against the Madeira. The biggest difference is because of the precipitation. The Negro Basin is the highest precipitation area in Brazil, and here we see that the highest period in terms of precipitation is the month of May, and the area is the highest area in terms of precipitation in this part. I mean, São Gabriel da Cachoeira, the place where the first photo was taken. And here we have a difference in terms of elevation from São Gabriel da Cachoeira until Manaus through the basin in the river. So here we have São Gabriel da Cachoeira, Serrinha, and also Manaus. And here we can see the vegetation non-flooded, and the area, the blue area, is the flooded regions in the area. Specific in this portion of the basin, we have flooded forest called in the area specifically as Igapó. And here we have some information, about the width of the rivers, the slope, and the sinuosity. which is very interesting to see, is that, for example, in this region, Negro, we have between 2 and 10 kilometers in terms of width. In fact, if we consider some islands we have here at the archipelago here called Mariua and the other one here called Anavilhanas, we can reach much more than 10. Next up. And here is just to give you an idea about the scale of the basin. So we are going to analyze some data here in the region of Serrinha and Caracaraí in this first graph. After we also see this region more in detail. I mean, this is the Anavilhanas archipelago, which is the region we concentrate more studies from since 2018. And here is the central part of the Anavilhanas, which is the national park, the Anavilhanas National Park. And here we have the hydrogram from 2013 until 18 with the campaigns, the field campaigns we have done, and the hydrograph from this period. So we also have several points where we collect samples and measure the water discharge. And here we measure the water discharge with an ADCP, a 600 kilohertz Rio Grande, and we also collect the samples with this kind of engine. It's a kind of Van Dorn bottle, and all the samples from this equipment passed by filters, and we have this kind of result. For example, here we have the Rio Negro in several points, and we also use satellite images, and we also use the radiometers in the field to validate the satellite data, to try to how I say, to pass from the satellite reflectance to suspended sediment concentrations. I mean, we differentiate and we try to correlate the watercolors with the suspended sediment concentration. And so we did this validation in the field, which is, I think, we are one of the few groups doing this in the Amazon. Normally, several works do this kind of use of a satellite image, but without this kind of validation. So that's one of the topics I'm going to show you in this today. So this is a paper we just analyzed the suspended sediment in the Anavilhanas archipelago. Here is just an example of the sections we use. This is in the entrance of the Anavilhanas archipelago. Manaus is here. And we have the entrance and the exit of the archipelago. So there is a huge difference. We want to show this, how the system works, for example, in terms of water, if there is a kind of redness of the water and of sediments, sedimentation, temporal sedimentation, for example, and something like that. And if we have also difference between the left and the right part of the channel here, because of the contributions from the Rio Branco. This is the biggest tributary of the Rio Negro in this part of the basin. So here we have the ADCP transects showing the difference between the entrance, the RN1 and the RN5. So we pass from 30 meters until 60 meters in the exit of the river. And the other figure we have here is the hydrogram normalized as well. So we can see some of the stations showed in this point. I'm so sorry, but I have problems with my mouse here. We also have in the lower figure the behavior in terms of the water level with the local water level at Manaus and the local water level in Moura, Novairão, and Santa Maria, which are some of the points shown in this figure. Let me see if So this is an this is an image, satellite image that show us with a false color, but that it's possible to see that there is a huge difference in terms of suspended sediment from the left bank to the right part of the river, the Negro River. So this is corresponds to the contribution from the Rio Branco, which is a whitewater river, and it changed. This contribution changed during the year according to the hydrological period the river is. So here we have the total suspended sediment in July from 2017, and in the lower water in November 2017, we have no more contribution from the left part because it's the lower part of the lower period from the Branco, and at July we have the higher period from the Negro, which means that a lower amount of suspended sediment and the higher amount of suspended sediment passed by the left bank. So it means that the Branco, this river here, has a huge importance to the Negro in terms of nutrients. This amount of sediments contribute a lot to maintain the biodiversity here in the national park. And here we can see the difference in terms of sediment. For example, here is the upper confluence with the Negro and the Branco. Here is the contribution from the Branco. Here is this point. So we can see clearly that there's not too much sediments in the Negro, only the Negro, but when we have the Branco and also the mix between the Branco and the Negro, we also have much more sediment. And here, the AN4 is the entrance of the archipelago, where the river becomes big in terms of width. And here we have the AN5 in the left bank, in the left channel. We have much more sediment than in the right bank. So it means that this is the way the Branco contributes to the Negro amount of sediments. And here is some data from this central area, and also all the most important stations we collected that data in the Anavilhanas, and also a view of the islands in the archipelago. So we can see that in terms of water sediment discharge, we have difference from the entrance and the exit of the archipelago. It means that there is a sedimentation in this area of the islands, but it's important to say that these islands are not under construction in a huge sense. I mean, the process that built these archipelagos, it's much more it's occurred in the Holocene. It's not a thing that's going on today. So this island is almost stable. So the Negro is a kind of a stable area. And here with the sediments we collected in the points, we use it to calculate and to model the evolution from 2016 until the end of 17, just to see how this amount of sediment changed from one channel to the other, in the left and the right, and in the center of the islands. So we can see that there is there is a huge dynamic from the left to the right side of the channel. But other thing that's interesting to say, that the concentration is very low. And here is thinking in a much bigger area, we can see the contributions from the Negro, from Serrinha, the station in the upper part of the river, and Caracaraí, the upper part of the Rio Branco, just to understand and to see how is the contribution to from these two branches to the islands here near Novo Airão. So those data came from the Brazilian National Water Agency and also from the HIBAN. But in HIBAN, we have much more data from the each stations because we collect data, we collect samples each 10 days in those stations since 1998. And ANA, they normally collect 2 or 3 times a year. So the results show us that in terms of contributions from Serrinha, we have 3.58 million of tons per year, and from the ANA data, and from HIBAN it's almost the same, but the big difference came from Caracaraí. And here we can see also differences from the entrance and the exit in terms of the amount of sediment in terms of depth. It means that we don't have a huge we don't have a big amount of sediment in the bottom, but it's almost homogeneous, you can see, and the surface normally is 2 times greater than in depth, but we don't have too much sediment, so almost the surface sediment is representative from what we have in the column, the water column sometimes. And so here we can see also the sample we use, the region, and this normally we used to take 3 verticals to collect the samples. So other authors did some studies in this area. Here, for example, is a paper from Fassoni Andrade and Paiva, where they used the satellite data from MODIS to reproduce the suspended sediment in the Brazilian Amazon basin. And they also, from this paper, we can have this image of the Anavilhanas as well. And we can also see that there is a huge contribution in terms of suspended sediment from the left bank, instead of the lower sediment contributions in the right bank. We also have a kind of mix at the end of the Anavilhanas in some period of the year. And here the data is not suspended sediment, but it's reflectance, can be which we try to build a kind of correspondence with suspended sediment. And here is another paper from Park and Latro-Bess. They use also the satellite data and try to associate with suspended sediment in the mixing point in the confluence between the Negro and the Solimões near Manaus. And after that, just to see how things change and how is the impact from one river to another, which is very interesting to see that how is the evolution and how is the dynamic of this confluence. So they produce this kind of figure, just showing how the system works in terms of the falling stage, the peak, and the rising stage. And here we did not only with the associating the image, the satellite images with suspended sediment directly, we did a kind of study to associate the suspended sediment concentration with the reflectance collecting those data of reflectance in the field with the radiometer. And also we did the same study using the MODIS data. It means the satellite data. So in this study, Marinho did some suspended sediment concentration interpolation in the area of the Amazon and Negro confluence. And we have this kind of image month by month here. With some months, they collect the samples. Here they show the the correspondence between the suspended sediment collected in the field with reflectance from the spectroradiometer, from the MODIS in the red band, and here is from the infrared band of the spectroradiometer and the infrared band of the MODIS. So they validate some of these procedures, and to produce this kind of map, the interpolation here, using the suspended sediment, the red band and the infrared band from the satellite, and also from the in-situ infrared and red radiometer data. This paper, Marinho, also another Marinho, but now Rogério, he did the same kind of experiment Thiago Marinho did at the conference, but at the Anavilhanas archipelago. So he used, here we can see the results, for example, for the RN1 here is upstream the confluence with the Branco. So we can have in high and low waters, the signal. We also have the Branco signal, which is very, very different from the Negro. I mean, this is the reflectance, and here is the wavelength. And here is the RN2, I mean, upstream the confluence, downstream the confluence. And here we also have the black one. Black lines is the high water, and the gray lines is the lower water. Here we have at the entrance, near the entrance of the national park, the Anavilhanas National Park, we also have kind of behavior that means that the Negro is becoming dominant. Here at the RN4, I mean the right bank, more Negro contributions, and how Negro is really strong. In the left bank at the RN5, we also have the strong participation of the Branco. I mean, it's the signature from the Branco is here, also in high and low waters. And we can have here at the exit, we have the signature part of the Branco contribution, but only in low waters we can see, and in high waters we have almost the Negro waters, the black one. So here we have different in terms of colors. For example, the Branco in July, that means normally the high water level, and here is in November, it means the lower water level, and the water, the Branco River water becomes more green. And here is the Negro in the high waters. Here is the Negro in the low waters. So just to show you what we have in terms of in terms of the signal from the Sentinel-2 and the locals, the in-situ data we obtain from the radiometers. Here we have a comparison between the reflectance and the water level, just to show the RN4 and RN5. Yeah, this is with using this equipment, and this is using the samples we collected, the water samples we collected at the river. So there are some data, we don't have data, so we can use the data from the radiometers. Here is a correlation between the observed suspended sediment and in here how is estimated using the radiometer data. And just the photo is here just to show you how is the black water behavior. In fact, when you look from a very, very shallow part of the river, it's not so black. In fact, it's much more brown than black. And now when the river becomes deeper, and so the water becomes really black. Well, so using the data from the satellite only, we have this kind of behavior. Here are the right and the left part of the channel in 2017, in May, here in June, July, and so on. So we can see how the suspended sediment estimated by satellite can be used to monitor suspended sediment evolution and dynamics in the Anavilhanas archipelago. Here is an area, an upstream at the archipelago, and we did some transects here just to see the difference between high water and low waters in terms of suspended sediment obtained from their radiance. Here is another example, but using this data from suspended sediment concentration just to show the evolution from the several stations. Here is from Serrinha. Here is the upstream, the confluence, the Branco with the Negro. Here is downstream, the confluence. Here is the entrance of the archipelago, and here is the exit of the archipelago. So we can see this in the January, February, March, and April, and here in May, June, July, and August, and we have an augmentation in here from September and December. It means in low water periods. Here is a graph that shows the evolution from suspended sediment against water discharge. And the difference we can see, this part here is in Serrinha, and here is at the Rio Branco. So we can see that we have much more sediments here at the Branco than we have at the Negro. Serrinha, it means the Negro. And we also have a pole here that means the low water period, and here is the pole that means the high water period, the same here. So we can see the evolution of this suspended sediment with the water discharge. And here we also have the contribution in terms of suspended sediment water discharge from the Branco and the Negro using the MODIS data. And here, again, we are using we are using the satellite data, but not more the MODIS, but the Sentinel-2 data, just to see the same phenomenon we saw at the MODIS. So here we have from March 2017 until October 2017. And these are the periods we collected at the hydrogram. And we also see the same phenomenon we identified with suspended sediment collected in situ and with the radiometer as well, and also with the MODIS data. Here, again, the part of, we did another transect with the AN5, 4, and 6 here. This is a big and huge lake in the middle of the island. So we can see here 10 kilometers per 5 kilometers in width. And there's a complete different dynamics from the channels. And here we have the signature of the suspended sediments using the reflectance. So with those data, we can build a kind of temporal variability of suspended sediment at the central area of the Anavilhanas based on the data from the Sentinel-2. And these points here are the water level, and we have the evolution of the suspended sediment in each one of these 3 points here. And now we can use the data, the traditional data, where we validated with those methodologies. We can produce a kind of histogram for suspended sediment discharge from January to December for several stations in the region we analyze. So we have here Serrinha. We also have the Branco, the entrance of the Anavilhanas archipelago, and the exit of the Anavilhanas archipelago. So we can see that there is a interesting phenomenon showing us for example, that Serrinha is almost stable, but when we have here the exit of the archipelago and the entrance of the archipelago, we have a difference, especially an augmentation of this suspended sediment discharge in the second part of the year. So when we are looking for a kind of suspended sediment budget, we can see that from Serrinha we have 5.06 million tons per year and 2.42 from the Rio Branco, and here downstream the confluence we reach 10.8. Means that there is more contribution from other rivers here in terms of suspended sediment that put suspended sediment into the system. But when we look at the exit of the Anavilhanas archipelago, we reach to a value less than this point after the confluence, meaning that probably we have a sedimentation area here at the archipelago because of of the width, and also because of the backwater effect from the Solimões with the Negro, with the reduction of the velocity of the water. So we have here the work we did in 2009 that showed total suspended sediment water discharge in terms of 8 million tons per year, and with the marine work we reached 9.28, which is almost we can consider almost the same. And we also identified that during 1 year almost 60% of the sediment is staying in the Anavilhanas archipelago, and after that in the other part of the year this sediment is resuspended and put in the system again. Here is just an image using this Sentinel-2 to show you how this system varies in the end of here is the exit of the archipelago, the area, and just to show you how the system works. And that's what I want to show you. And if you want to see more, especially if you want to see more images, you can go to this address here at the Instagram called the Hills Online, and at this point you can see a video of the confluence between the Negro and the Solimões. That's it, Juan, and thank you very much for the opportunity. I hope I can answer some questions from the public, and if you have other questions as well.
Naciano, thank you very much for this marvelous traveling to the Negro River and its role in the sediment transfer to the Amazon River. Now the section for question is open. Remember, for the attendees, that you can send your question through the chat. So please send us. In the meantime, I have one question, Naciano. You show us a vertical profile of suspended sediment concentration showing large amount in the surface, which is opposite than the typical vertical profiles expected with larger values in the bottom. Which processes would lead to these such vertical profiles?
You mean the difference between the surface and the bottom of the concentration? Yes. Well, in fact, we have some phenomena in the Negro, especially after the rain. We also have an explosion of algae and also organic matter as well, and then we have much more suspended matter in the surface than in the bottom. And normally we have to separate this, and we have to put it out. I mean, just to consider the mineral part of the suspended sediment if you want. But normally we use with the procedures and the protocols we use, we take a little bit of it into the samples. So this is because of really the matter, the organic matter we have in the surface. because one of the reasons the water is black in the Negro is because of the humic and fulvic acids that comes with this organic matter.
Oh, great. We have one question from Luis Antonio Pereira de Souza. Congrats for your wonderful work, Dr. Naciano. Why not to try to measure the thickness of this sediment downstream from Anavillanus archipelago by seismic profiling?
Well, it's I really don't know. I mean, the thick of the bottom, probably that's the mean of the question, isn't it?
Yeah, so I guess
yes, that's a good question. We are in contact with some colleagues, and we expected to even Luis as well. He is invited to us to help us because I know he has the equipment to do this, and this will be a very good opportunity to do this kind of approach, to use the seismic equipment and to check how is the thick of this bottom at the Negro River. In fact, we don't have this kind of material here at the university, but if there is someone that is interested in this topic, we can talk and probably do some project together.
Great, Naciano, thank you. I have another question from myself. You showed us a lot of pictures and plots from the Amazon and Negro River measurement, but I guess that there is a lot of logistical support and effort behind such measurement, because we're talking about the largest river on the world, with several connotations about the surrounding landscape. What would be the most difficult things in order to achieve such measurement? I mean, security, transportation. What do you think is the most challenging issue when you are going to do your measurements?
Well, in fact, it's very difficult to say that we have one point that's the most difficult. It's a complex operation, and normally it depends on the part of the basin you are talking about. For example, at the upper part of the Negro, I mean, before São Gabriel da Cachoeira, the region of the map that is like a dog face in the Brazilian map. So this area is an indigenous area, and normally there are problems with the invasion of these areas and some kind of illegal minings, etc. So the army is there as well, and we can use a big boat. We normally use small ones, so we have to camp, and it's very huge to do the work. Yeah, but downstream São Gabriel da Cachoeira, we can use big boats. It's more comfortable, and normally we do the job with more peace, I mean. But what is other thing is to have money for all the logistic aspects. I mean, how to transport things, goods, and other things. It's not easy, and how to put all people together also in a boat. Normally, we have people doing water discharge measurement, other one doing geochemistry measurement, other one doing just altimetry, and so on. So it's a heavy mission to put all these people together, talking together, and trying to obtain some data and to obtain some results. No, so it's also a difficult we have. Maybe this is one of the biggest one.
Yeah, definitely that gives you more value to your results. Definitely. We have a response from Luis Antonio Pereira de Souza. Yes, well, will be a pleasure for me to help you to discover these hidden sediments there. So you have a new partner, Naciano.
Not so new. I know this guy.
Well, there is a question from Joges Agrawal. Naciano, do you have sediments grain size data at this station? What does that tell you? For example, does the size variation explain the scatter between suspended sediment concentration and reflectance?
Well, this is a good question. We have those data, but until now, we don't have processed all this data because it's very complex. And it depends of the region. If, for example, we are at the part of the Branco River, we have a different kind of grains in terms of size. And also the variation between, we have much more sand than silt and clay. And we have much more clay at the right part of the channel. So, but it's complicated because how it depends of the period of the year you are. So we have difference. As I showed in the one of the images, we have a point in the center of the river that we have a variation in terms of suspended sediment during the year. And also we have a variation in terms of grain size, okay?
Thank you, Naciano. During the lecture, you also mentioned that you start to realize, to perform measurements back in the 90s, right?
Yeah.
In such a time frame, the Amazon has experienced a lot of anthropogenic stressors, gold mining, illegal, deforestation, and everything. So, have you found evidence or signals of such perturbations on your measurement? I mean, in stream flow, suspended sediment concentration, grain size properties, or something showing the effect of such anthropogenic stressors?
Well, the signal was cut several times, but I think I understood. You asked that if we have some impact, anthropogenic impact, and if we can have some signals in our data, isn't it?
Yeah.
Okay.
Yeah, that is.
Well, in fact, in terms of suspended sediment and water discharge, we don't have this signal in a very strong way, you know, because it's good to say that the Negro Basin is not so, we don't have so huge amount of illegal minings and anthropogenic influence against the river, the Negro itself. But at the Branco, we have some problems, and we have some change in terms of turbidity in the rivers, but in the very upper part of the basin. I mean, the Mucajaí and near the frontier with the Venezuela. So this will be very. This not will be. In fact, this is a big problem we have now with illegal mining at the upper part of the Branco Basin. At the Negro Basin, we still are doing some work in some tributaries, small ones, because of the side of the Negro is so big in terms of dilution. Maybe it's probably play some role in this scenario, I think. But the most sensible river in this basin is the Branco one.
Okay. Well, I have a final question. Is like it's a sort of institutional questions. You mentioned that you have more measurement and more frequent system of measurement through IBAN than the frequency associated to the ANA measurement, right?
Yes.
ANA is the official network for measurement in Brazil, right? So
yes.
That means that most of the knowledge that you have about the Amazon behavior, the river behavior, come from such an association. From, as I understand, it's an international institution, right? Can you tell us a little bit more about IBAN and their importance in knowing the dynamics of the river in the Amazonian basin?
Okay, well, in fact, we work together with ANA. It's a complementary kind of studies.
Okay.
Because ANA, they have a huge network. They have several points, more than 100, more 200, I think, 200 points in the whole Amazon in Brazil. But we, in IBAN, we have only 9 points. So with these 9 points, we can do much more, put much more effort in terms of producing more data and with more frequency. And so we complement somehow we complement the data of the Brazilian National Water Agency. And there is, well, these 9 points in Brazil, but in the whole Amazon basin, we have 41. And those points contribute to understand how the sediments and all the hydrogeochemistry elements and products came from the Andes until the mouth of the Amazon, how the system works. This is what we are trying to understand, and how it changes during the time. So we are doing this since 2003, and for some stations even from the 90s we have data. So that is the importance of IBAN in this the Amazonian context. And we also developed a protocol in accordance with the WMO protocols, and also with the UNEP protocols and all the international initiatives. So this can be used to form people at the basin, technical formation from our people to all the technical agencies in the Amazon. So we collaborate with the ANA, we collaborate with CPARM, the Brazilian Geological Service, and other agencies as well. And we also collaborate with the ACTO, the Amazonian Cooperation Treaty Organization, to support their work in terms of water resource management system in the Amazon. And this is I think, the main importance of IBAN in this context.
Okay, great. Cooperation as a key role in scientific improvement.
And I have to say that the data is all the data is open. You can reach at the internet, and you can download the data and as you want. So IBAN data is a free data.
Okay, great. I have another question from Yogesh Agrawal. Are you considering using drones to make many more near surface measurements of suspended sediment concentrations?
Yes, we are now in a project with the people from University of Brasilia and IRD as well, and also with people from Ceará. They are trying to use drones for measurement the draws and all the sediments in terms of draws in the rivers in the Ceará, with the small one. And we are now here trying to use drones for big rivers. And we also use special cameras as well, to trying to reproduce the measurement we do with the hydrometers, the in-situ hydrometers using this camera. So you can see some of the images we did with the drones, but just like photos and so on at the Hills Online website. I show you the address. And but we are also trying to test this kind of research, I mean drones, to measure and to do a kind of an ensemble of signature from drones, and put all this in a database for trying to use this to measure sediment and compare the data from drones to data from satellites and from in situ as well.
Okay, Naciano. Thank you very much.
It's a pleasure.
I want to thanks for your involvement in this initiative of PiA Webinar Series. It was great to hear the story of your measurement in the Amazon basin, which is great, is amazing, considering all the efforts behind all the results, that you have gotten. So Naciano, thank you very much for being here, and thank you very much for everyone for attending this PiA webinar series. I want also to remember you that you can visit our webpage in order to check this webinar and also the past webinar, as well as related information. For example, the Instagram site that Naciano just mentioned, it will be available through our webpage in order to know a little bit more about this work of Naciano and his colleagues. So thank you very much for this session, and see you next.
Okay, thank you very much. See you next. Bye-bye to everyone. Bye-bye, Juan.
Bye-bye, Naciano. Have a good day.
Bye.
Los siguientes contenidos de Uninorteco te pueden interesar. No olvides suscribirte a nuestro canal.